Okay, so let's do the circles unit. It's at the end. I usually spend like 6 or 7 classes, but I'm doing this in 40 minutes. So uh, let's see. So the first unit of the circles chapter is tangent lines. So let's call this circles. The first thing is tangent lines. Now, we've used the word tangent. No, once again, I'm assuming that you have a basic lesson on circles. Circles is a set of points equidistant from a center. There's a radius, circumference, diameter, area, all that stuff. Tangent line. Now, we've used this word tangent in trigonometry. You know tangent from trigonometry, which is like TOA, opposite. Tangent of an angle is opposite over adjacent. Maybe we've talked about maybe it's like slope, but we're going to use it in a different context here. It's not different though, actually. It is connected. We just don't have enough, we're not there yet in trigonometry for me to start connecting it. So, 2 things. So tangent, first of all, we have a circle. Every single one of these questions, we have a circle with a radius. It goes without saying. This entire unit, there's a circle with a radius. And so the idea is the first line, this is a line, and this is known as a secant. Another important word, it's a secant, and it's a line that passes through a curve at 2 places. I should use the word intersect, but the idea is it passes through two places. What we're interested in is looking at really close up areas, because you might say, well, could it be 3 places, Mr. Adler? And in a future class, you're going to be looking at something like this curve, and you might say, oh, is this a secant line? It is, but we're really interested in this region here. I want you to start to. We want to get involved in the neighborhood, really close what's going on. And it's important because of the next word, which is a tangent line. A tangent line, this is a tangent line, and the idea is it's a tangent because it intersects the curve really locally at one point. So once again, you might say, well, Mr. Adler, I might draw, for this one, I might draw a tangent here. And then you would say, hey, Mr. Adler, but that line crosses the curve over here. No. When we talk about lines intersecting curves, when we start talking about the idea of a tangent, because we can have the question can be name all the points the line touches the curve, and you'd be like here and here. But when you start hearing the word the tangent line, what's implied is that you're getting really close to this neighbor. You're getting right in there in this neighborhood. You want to know. Once I take a microscope in here, does the line touch the curve at 1 or 2 places here? And that's the idea of the tangent versus the secant line. And if you think about it theoretically, the tangent line is a secant line where both points end up at the same location. A little advanced right now, but that's the idea. Okay. So, what else? So, let's continue. This point here, where the tangent line, this is known as the point of tangency. This is the point of tangency. Okay? And it's often been, it's the point where the tangent line meets the curve. What else do we want to say? Oh, and it turns out, this is kind of cool, the radius is perpendicular to a tangent line at the point of tangency. The radius is perpendicular to a tangent drawn to its point of tangency. And you can visually see that here. Here's my center, here's a tangent line, here's the point of tangent, and when I draw my radius to it, it's perpendicular to it. Because of time restraints, we're not going to prove all these things, but you can imagine, you could, create, triangles and everything that follows. Let's move on. And so let's just do some exercises. So for example, let's take a circle right here, and I have the radius. I have two tangents drawn from a point. Okay. And so here's the diagram. So let's see. AB and CB, let's see. AB and CB are tangents drawn to circle D. Okay. And so if this angle ADC is 117 degrees, find the measurement of x. And you would say, okay, this is no big deal because we're told that these are tangents. The radius drawn to is perpendicular here. And because BC is tangent to the circle at C, the radius DC is perpendicular here, which means it's a quadrilateral triangle. And you can clearly see that 117 plus x plus 180 equals 360. X is equal to 63 degrees. These are the type of problems that show up in this unit. You might see another problem. Let me pause this. Okay, another problem is, here's another circle. Once again, we have a circle. We have, let's say this is the diameter. This is the diameter, and let's say this point is tangent over here. And we have the segment over here, so we know it's perpendicular. That's the idea. They're bringing back right triangles. This is 38. Find x. And you would say, oh, you know what? We're told it's a tangent. This line is perpendicular. Therefore, that's a right angle. So x plus 38 is equal to 90. X equals 52 degrees. Another thing, they might, once again on the Regents example, you might see on a state exam, wherever you are, here's another circle. Let's say we are told that this is a radius, this line is a tangent, we're told, and then a secant segment is drawn from this point here. So let's call this A, B, C. AB is the radius. AC is tangent at A. So you're like, okay, it's a right angle. And then they give you the sides. They say x, 12, and 8. They're prepping us for a later unit. And so you'd say, you know what? So we have x squared plus 12 squared is equal to x plus 8 squared. Hey, Mr. Adler, where did the x come from? It's the radius, because all the radii in a circle are equal. And then you use Pythagoras, you expand it out. X squared plus 144 is equal to x squared plus 16x plus 64. You have to know how to expand a binomial. This is easy. The x squareds go out. We have 6x equals 80. X equals 5. The radius is 5. Let's try another one. We were given this diagram. Can I draw it down here at the bottom? Because I don't feel like, yeah. We are given a circle here. We're told that this is a segment. We're told that this is a segment. We're told that this is a segment. We're given the sides, 3, 4, 5, and you're asked to prove this whole segment is 5. You would say, is, let's call this, A, B, C, and you would be asked to prove, is AC tangent to the circle? And you would say, yes, because, so is AC tangent to circle B? And you would say, question mark, you say yes, because AB, because this is a right triangle, you say they're perpendicular, and yes, because AB is perpendicular to AC. That's the idea of those exercises. Let's see. Couple of interesting, two tangents drawn from the same point are congruent. I'm sorry. Two tangents drawn from the same point are congruent. I'm going to get another marker because I'm running out. This is going to be a long video. Maybe I should just make a couple of videos. So we have a circle, and we have some exterior point. So once again, we have a circle. Two exterior points. So let's draw a tangent here. Let's draw a tangent there. So we have A, B, C. Let's call this circle D. And the claim is that A and B, AB and BC are tangents. And the claim is that AB is congruent to BC. So what would that proof look like? And you would say, okay, no big deal. We know that we can draw on the radius. So the first thing is we can say that AD is congruent to DC because all radii are congruent. Two, who's not? The second thing we can say is that AD is perpendicular to AB and DC is perpendicular to BC because a tangent is perpendicular to the radius. So let's see. We have congruent. Well, obviously in proofs, it always comes down to triangles. And you say, oh, you know what, Mr. Adler? Let's draw this line in here. Well, BD, to construct BD, and then say that BD is congruent to BD. Why? Reflexive. Are we done? Well, we side angle, that doesn't work for Mr. Adler, but these triangles are congruent. So ABD is congruent to triangle BCD. Why? Hypotenuse leg. Number 5, AB is congruent. AB is congruent to BC. How that shows up on the exam, I'm not really sure. But once again, if you draw two tangents from a point, they're congruent to each other. And let me put those markings in. Yeah, so these are congruent. Now, another cool little thing is if you inscribe a circle inside of a triangle, right? So if you take a triangle, now we saw this in the special triangles. I asked you to you take a triangle, and then you draw all the perpendicular bisectors, and then you're actually able to, with that center, you're actually able to inscribe a circle inside of a triangle. And what you notice that these fun little questions, maybe they show up on the SAT, you saw it, you didn't know what it was. The idea is that these are all tangents to the circle, and now you can say that this segment is congruent to this segment, and this segment is congruent to this segment, and this segment is congruent to this segment. That was the point of these, that's the idea. So, and that's another little thing. Yeah, that's basically it. So how are we doing for time? 14 minutes? Okay, you know what? I'll make a little. I'm going to stop this movie now.